Hello students, welcome to SH Math Lessons. So today we are going to look at Introduction to Sequences. We are also going to see how to find a rule for sequences. Now there are two ways to go about doing that. So we're going to look at inductive and deductive rule. We're also going to look at a few different types of sequences. Yes, the easiest one is the linear sequence, and then we'll also look at recursive sequence. So let's go ahead and understand a bit about sequences. I do know that a number sequence is nothing but it's an ordered set of numbers with a rule for finding every number in the sequence. Now the rule takes you from one number to the next, could be a simple addition or a multiplication, but often it is more tricky than that. You always need to look very carefully at the pattern of a sequence. Now each number in a sequence is called a term, and it is in a certain position in that sequence, and that position is called or denoted by UN. Now let's take some examples here. So if I take up the first example, which is 3, 6, 12, 24. Now before I call out what the rule is and give you a few values after this term in the sequence, please go ahead and pause my video so that you can first think about it and then come back to my video to understand what is the rule of this sequence. So this sequence, if you see the rule, is doubling the previous term each time, and therefore you are going to see that the next number is 48 followed by 96. Looking at the next sequence, if you see that it's 2, 5, 8 and 11. Now, the rule for this sequence, yes, it's adding 3 to the previous term each time, and therefore your next term is going to be 14 followed by 17. Looking at the next sequence now, it's 1, 10, 100, 1000. So now if you look at the rule for this sequence, you will see that it's multiplying the previous term by 10 each time, and therefore the next term is 10,000, 100,000 and so on. What about the next sequence here? Yes, you're subtracting 7 from the previous term each time, and therefore the next number is going to be 52 followed by 45. So now these are all quite straightforward, and once you are able to find a link for the first term or the previous term, you're able to get the next term, which is also called as the consecutive term. Look at the example here. Now what do you see in this example? This particular sequence is a very famous sequence, also called as triangular numbers. Now if you are interested in knowing about triangular numbers, I would want you to please Google it. You will see a lot of interesting facts about this number. So it's 1, 3, 6 and 10. Now what you will see and observe that there is not a common rule. You're not multiplying or adding with a constant number here. However, there is a pattern. So 1 plus 2 is giving me 3. That's the next term. 3 plus 3 is giving me 6. 6 plus 4 is giving me 10. So I see that I have to add the next number, which is going to be 5. 10 plus 5 is 15. So therefore the next number is going to 15. So I am increasing the number, the difference here, to be able to get my next number. Now these kind of sequences that do not follow a constant pattern between the previous number and the next number have a special place in the set of sequences and patterns, and we are going to talk about it a little later. Now let's get back to understanding how do you find a rule. Now when I'm looking at finding the rule, it's very important to understand what exactly does a recursive rule mean. Now, a recursive rule means it links a new term to the previous term in the sequence. All right. So, for example, here we have 3, 5, and 7. So, the next term can be found by adding 2 to the previous term, right? So, I can say that each and every time I add 2 to the previous term is going to give me the next number. So the recursive rule here is based on your previous term. So you know the previous term, depending on what exactly do you have to add, multiply, double, whatever you have to do to find the next term is the rule of that particular sequence. Alright, so this is the recursive rule for any sequence that we usually find out. Now coming to the next kind of rule that we can also look at. So the next rule is called as a deductive rule. Now the deductive rule links the value of the term to where it is in the sequence. So when we are looking at the deductive rule, it is looking at the position at which the term of the sequence is in. So for example, if I am talking about 1, 4, 9, 16, all right, here, now if you look at the table, it is the position of the first value here, which is 1, is 1. The second position, you have the term 4. At the third position, you have 9. And the fourth position, you have 16, followed by the fifth position, which is 25. So if we look at the position and correspondingly try to derive a formula for it, then we say that we are using a deductive rule to find the general term for a particular sequence. Now this deductive rule has a lot of other names as well. Deductive rule is a fancy name. As I always told, mathematics does have a lot of fancy names. So I'm sure you've always heard in your previous grades about finding the nth term of a sequence. Well, you're using deductive rule here. Deduction is an important skill in mathematics, and that's exactly what you're doing. It's also called as inductive rule, or simply just finding the formula to find the terms in a sequence. So let's now go ahead and look at the different types of sequences. So the first sequences that we're going to go ahead and look at is the linear sequence. Alright, it is also called as arithmetic sequence. These are exactly the same thing. In fact, you do have a different terminology for sequences. In some books, you will see the word progression used, and these are absolutely the same thing. Now, a linear sequence is a list of numbers where the next number is found by adding or subtracting a constant number. Now, when we are talking about this constant number, it is helping us to get both the recursive formula, but at the same time, the deductive formula as well. So it will not be difficult for us to find the deductive formula, which is the nth term. So let's go ahead and take an example here. Now, if I am talking about 5, 8, 11, 14, and 17, the first thing that is important for us to understand what is our recursive rule. So our recursive formula that we know is that if I want to find the next term, I need to go ahead and use the previous term, and whatever difference that I have, I need to just go ahead and add it. Now this D is called as the common difference. If I am looking at the inductive formula of finding the nth term, alright, then I use this formula, which is UN, alright, UN here is the term that I want to find, alright, is equal to the first term, which is U1 plus n minus 1. Now, n is the position of the term that I am trying to find out, into D, which is the common difference here. Now, let's go ahead and solve this problem to be able to find both the recursive formula as well as the inductive formula. So, we have this sequence which we were going to solve to find out the recursive formula. So, our formula is given to us as UN plus 1 is equal to UN plus 3. right? Why? Because we do see that the common difference here is every time 3. Alright? So therefore, our recursive formula is going to be un plus 3. Now coming to the next one, when we are looking at try to find the deductive formula. To find the deductive formula, the first term that we know is 5, which is nothing but u1. If I want to go ahead and find my d, which is nothing but my common difference, it is going to be 3. Now, once we've got this, we are going to go ahead and substitute it in the formula that we know, which is un is equal to 5 plus n minus 1 into 3. So when we go ahead and expand this, it is going to be 5 plus 3n minus 3. When we solve this further, we get 3n plus 2. Now, just to check whether this formula is correct. Now, if I just go ahead and say, for the first position, I need to find the term. So, 3 times 1 is plus 2 is equal to 5. That's the first term. If I want to find the second term, it's 3 times 2 plus 2 is 8. So in doing this, we are able to find the term for that particular sequence. Now, what is the difference between the two and how important are these? Now, recursive formula is very helpful if I want to go ahead and find out the next term, considering that I am not able to find out the general term of the sequence. Also, there are times when you are not able to see a general term, a common pattern across the board. Then the recursive formula is very helpful. Deductive formula comes into play when we are looking at finding terms that are way too huge. If I am talking about finding the 100th term, let's say, for this particular sequence, then it is going to be very difficult for me to use the recursive formula each and every time to be able to find the 100th term. Therefore, that's when the deductive formula comes into play. Now, let's proceed to understanding the next important set of sequences. So the next important set of sequences that we should know about is the recursive sequences themselves. When we are looking at recursive sequence, these are a sort of sequences where you get the next term by doing something to the previous term, and therefore they are called as recursive. The important part of these recursive sequences is that you really do not have a common pattern that you can say which will help you to find a deductive formula for it. Therefore, these are recursive sequences. A very famous example that I have put up here for you to see is the Fibonacci sequence, and I'm not going to talk about it much because yes, you have an investigation on Fibonacci sequence and a fantastic TED talk by a mathematician, Arthur Benjamin, that I would like you to have a look at. Alright, so okay, see you in the next video. Bye-bye.